Hello everyone. See you again on online class 9, chapter 4. So this is the last video for you to prepare midterm test. So this is very important because the test is covered in chapter 1, 2, 3, and 4. So let me share with you the slide. So let's continue. So this video is continued from the previous online class 8. So if we're not mistaken, I've I stopped somewhere here. Okay, let me share with you again. So this is the see. Let me take the back. Okay. So I think at this color space. Mm, So I think last video I stopped somewhere here. So hopefully you can understand how to what is the color thresholding here. Okay. So ask you to do this example. So you can try to do this example. And next is another space of color, HSL, hue saturation minus, and HSV, hue saturation value, are two alternative representation of the RGB color model. It was designed in the 1970s by computer graphics researchers who more closely aligned with the way human vision perceive color making attributes. So in these models, color of each hue are arranged in a radial slice around the central axis of neutral colors which range from black at the bottom to white at the top. So this is the detail about the HSV. So the HSV representation models will weigh beams of different color mixed together. So this is detail lah. I don't want to explain or discuss this one, but it is just enough for you to know that another color space besides the RGB is HSV. And the HSL also. And HSI. So HSI, what is HSI? Hue, saturation, and intensity. H and S may characterize the color or intensities, hue, saturation. So, for example, if you have this, so this is the definition of HSI. We have hue, saturation, and intensity. Like the RGB color space, uh, there are red, green, and blue. So HSI, hue, saturation, and intensity. So this is the HSI color space. A single pixel consists of three components: okay, hue, saturation, and intensity. So this is the example: hue, saturation, and intensity. So there is a way how to convert the RGB to HSV. So this is the This is all the step of conversion. If we have an RGB image format, we can convert into HSI by using this formula H theta S in tensor. This is the RGB. This is also RGB. So just apply this formula, then you get the HSI by converting of RGB image format. So we have also HSV. So this is the formula for HSV. Few color spaces. This is example, so you can go through this example. How to convert HSV from RGB. Okay. So you can also try this exercise, convert image to HSI. So we have 8 input, so you can do all the calculation to convert the RGB to HSI. Next is we are still in the color image processing. So this is a segmentation based on segmentation based on okay. Figure 6.42 image segmentation in HSI space. A is original. This is original. This is original. Original image. I'm not sure what kind of this image, but we can perform image segmentation based on color because we have a color yellow, red. So B, if we go to the HS, this is by using HSI, Q space, then we got this. If we display hue, we got that. So it gives some segmentation region. Go to saturation, is intensity. If we perform binary saturation mask, threshold equals to 10% of maximum value. And if we multiply mask with the Q image, so we got this one. Okay. A, B, C, D, E, F, G. What is G? Histogram of F. Histogram of F. Histogram of this one. H, segmentation of red component E. Got this red component. So this is an example of segmentation based on color. Okay, this is more detailed calculation of RGB color space. So you can, so if you want to find the sources, so you can have this image processing consultancy. Given a set of sample color points of interest, obtain an average color to segment RGB vector A. So this is what I want to explain. So, this is the method. Okay, so if from here to here, we can segment this region color based on color, red color. This is for red. Segmentation in RGB space, original image with colors of interest shown enclosed by a rectangular. So this is the area or the region that we want to segment. So result of segmentation in RGB vector space compared with data space. Compute mean vector of a color points in rectangular. Compute the standard deviation of break in an box centered on a dimension along each RGB exists one. Okay. So next is a LAB color space. Color space defined by the CID based on one channel for luminance and two color channels A and lightness and two color channels A and B. So LAB. So this LAB is another color space beside the RGB, HSI, HSP, so on. So this is the spectrum. Difference between green and greenish yellow is relatively large. The distance between blue and red is quite small. The CIA solved this problem in 1976 with the development of the three-dimensional lab color space, side C-lab color space. So this is all the discussion about the LEDs. The color image recognition techniques is widely used in the remote sensing control, geological investigation, cartographic data mapping, and so forth. It is necessary to do that in automatic, reliable, and fast way. So this is why we do the image processing. Okay. Okay. So this is an example of color image processing or color image recognition, color image segmentation. We have this is basically the whole idea. Image, data acquisition, we do pre-processing, mesh enhancement, find feature extraction based on, then we go for classification of processes. So this is the example of remote sensing. Want to find the color? This is step classification. Okay, I give you more practical example and very simple, not the detailed example, very general example for color image segmentation or color image recognition. So detection of pineapple. So this is example of pineapple. Okay, so in order to do the quality inspection of this pineapple, so the inspection can be done by looking at the color, the yellowish, yellowish. More yellowish, this is yellowish. So more yellowish means that fruit is mature or maturity index deformity. Okay, so for the color face detection, also for the face detection, this is also based on color, can be based on color. But nowadays, people do the face detection by using machine learning or deep learning. But this is the conventional method based on color, right? Because when you look at this face, immediately your brain can know face have some color which is different from the other colors in the background. This shirt. And so color can be used for color segmentation or color detection can be used for face recognition. So this is a step for face. Okay, if you look at this face, then you get some colors. Face. So the first step is convert RGB to gray. Why we need to convert RGB to gray? Because RGB is three-dimensional, gray is two-dimensional. Normally, for the image processing, we do the two-dimensional. We don't analyze in three-dimensional because it's difficult. Three-dimensional compared to one-dimensional. 2D straight. Okay, so that's why we need to convert RGB to gray. So no more color, but still have some information of color, although we convert it into gray, because this is a RGB, this is a gray. 0 to 5, this is 0 to 5, but this is RGB. Okay, we can see the difference of color between face and other. Oh, we can use color segment. Next, convert the grayscale image into PWM. Convert the grayscale image into PWM. Because grayscale is 0 to 5. Convert to PW, which is 0 and 1. So easy to analyze because we only have 2. Back to this one, 0. This is 0. Face or not face. Background or ROI region. So we convert to grayscale image. So how to convert? We can set like this. 0 to 150, for example. This one change to 0. 151 to 255. This is changed to 1. So finally we get here and we get in what? 0 and 1. Okay. There are a few methods of recognition, but the simplest way is like this. Okay, due to the difference of color components of face image in PW, we produce region of object in it. And when we do conversion, we get only 2 value, 0 or 1. So easy. And it's easy to analyze compared to 0 to 1. We have range of value. So when you convert, then you can make it region. Background, region 3. Background. This is black. This is black. This is face, region number 1. This is region number 2. But because this shirt is similar to this one, that's why we need to segment. Okay. Select face region. Okay, from here, select the face region, which is face region 1. So how to select? And then you have to perform. We can analyze the region and determine its face. Select only face region for eye, nose, and mouth. So after we select the face, then we go to the eye, nose, and mouth section, because these 3 components in human face is very important for recognition. Then we make it box, and finally we make it box to detect image. Okay, so that's all for this slide. So let's see what we get. Another slide. I open the yes. Okay. So that's about color. We are still the segmentation. This is an example of detecting cell using segmentation. So you can go to the MATLAB and run the demo. So that's all the color segmentation. Now we go to the image segmentation thresholding. So far we have been considering image processing used to transform image for image recognition. We will begin looking at the automated image analysis by examining the thorny issue of image segmentation. This is more details on the segmentation. Segmentation attempts to partition a cell of an image into groups that strongly correlate with objects in an image. Clearly, the first step in any automated computer vision. For example, this one. Then we perform. This one. Then do segmentation. This is another example. If you want to detect this black color, then we need to perform this. This one is difficult. Here, you can do segmentation. Z and count. There are three basic types of gray level discontinuities that we tend to look for in digital image. Points, lines, and mesh. We typically find discontinuities using mask. So, discontinuities means that segmentation. Yeah, because now we are talking about segmentation. So, in order to do a segmentation, we have to understand that what is the discontinuities in these 3 points. Okay? Yeah. Point detection can be achieved simply using this mask. Points are detected at those places in the subsequent filtered image that are above a set threshold. So this is we want to detect this one. We perform point detection. This one. And go very tiny point. And we perform this thresholding. We remove other region that we don't want. So this is the point detection. Next level of complexity is to try to detect lines. The mask below will extract lines that are 1 pixel thick and running in a particular direction. So we can use this line detection for wire bond mask to the special mask. So edge detection, what is edge? An edge is a set of connected pixels that lie on the boundary between two regions. What is edge? This is an edge. Usually below, when you have, for example, 0 and suddenly you have 1. Then it is formed an edge. Kalau if we have this ram here, then that's why you see blur. Because the changes is gradually increasing. So this is molecular, first derivative, second derivative. So we can use detectors, common edge detectors. Any point now, common edge detectors. Roberts, Revit, and so on. This is an example by using edge, horizontal gradient component, vertical gradient component, combined edge. So this is a problem, edge detection. Often problem arises in edge detection in that there are too much detail. For example, brickwork, the previous example, one way to overcome this is through smooth images prior to edge detection. We do the smoothing. So this is more details of edge detection by using Gaussian option. Next, we go to the segmentation. This slide a little bit mixed. At the beginning is segmentation, age. Now comes segmentation again. But try. I hope that you still can get all the information. Segmentation divides an image into its constituent regions. Segmentation of image is difficult. So this is an explanation about what we discussed just now, what I explained to you just now. Segmentation of image is a difficult task in image processing. Still under research. It allows extract objects and images. So it has a lot of useful segmentation algorithm. So this is all the algorithm. As example, what original image segmented, original image was segmented. Okay. So I think this one you can just read. This is a segmentation based on threshold. We have two different regions. And for example, this one, easily you can do a segmentation. Okay, so the rest I think you can just look at this slides and it's not very important for the time being, but it's important knowledge for you. So that's all the video for chapter 4. So please watch this video for preparation for. Okay. That's all. Thank you very much.